Polyatomic ions then have poly more than one, atomic more than one atom in their ion, right? That's what polyatomic means, more than one ion. So you've got a table, and there's a whole bunch of them. These are a couple, well, three, that don't necessarily have a rule to follow when they name them. So you're going to just need to know them. Does anybody know what CN is? What will kill you if you... What will kill you? Cyanide. Yeah. That's cyanide. Oops. That's cyanide. CN -1. OH minus, you told me yesterday that you knew, hydroxide. And C2H3O2 is the acetate ion. We talked about that. How many hydrogens did each one of these lose? One. So this could have come from HCN, which is hydrogen cyanide. This one could have come from HOH, which is water, H2O. Which is the exact same thing as H2O. And then acetate could have come, if it's written like this, it's just hydrogen acetate. If you do this, it's acetic acid. Okay? Yes, this is actually dissolved in water, and you put it on French fries, vinegar. That's vinegar. Vinegar that you put on your food is about 3%. So 3% acetic acid, 97% water. Pickling vinegar is more like about 5 or 8, I think. Yeah. So can we do C2H3O2H? That is also sometimes the way it's written. And the reason is it's an organic acid, meaning it contains carbon and hydrogen. And its formula, its structural formula is actually that. So a functional group is a group of atoms that identify or determine what type of a compound you are. So in terms of organic chemistry, this is the functional group for an acid. And what happens is that, bless you, that H is the H that pops off as an H+. Ammonium is +1, and H3O+ is the hydronium. So these are your positive polyatomic ions.
What about mercury?
Mercury is an element. We get into oxyanions, which are negative ions with oxygen. SO4 2-, NO3 1-. And to name these, you take the element that the oxygens are bonded to, you take off the ending and you add 8. So that's the sulfate ion. That's the nitrate ion. The most common ion ends in 8. If you lose 1 oxygen, your charge does not change, but your name does. So we talked about this yesterday, and it just comes down. So it's nitrite. So that's 1 less oxygen than most common. Now when we come to the halogens, we have something a little different. This is the most common ion for chlorine. This is the most common oxyanion for chlorine. What would you name it? Chlorate. So what would you name this? Chlorite. Now, you can also have this is really only going to be for halogens. Okay? So it's a little different. This becomes hypo, chlorite, and this one becomes perchlorate. So if you've got 1 more than the most common, you keep the most common name and you put a per in front. If you have 1 less than the lower version, the ite, you put a hypo in front, meaning low. Okay? So we've got perchlorate and we've got hypochlorite. So what would you call BrO2 minus? Bromite. What about bro? BrO. Hypobromite. Yeah. When you name acids, you've got to see 2 things in the formula. H's and AQs. Right now, there's no AQs. That is not an acid. That's just dihydrogen sulfate, dihydrogen sulfite. If I put in an AQ, different story.
Doesn't that have a charge? Does that go on hydrogen?
Here we go. When you have acids that come from polyatomic ions, you use the polyatomic ion to tell you what name of the acid it is. So if you have the 8 polyatomic ion, it's an ic acid. If you have ite polyatomic ion, it's going to be us or us acid. So H2SO4 becomes sulfuric acid, and H2SO4 becomes sulfurous. Okay. So then, what is HClO3 AQ?
Chloride. No.
Chloric acid. What do you think about HClO4 AQ? Yeah, it's perchloric acid.
Don't acids usually have hydro in them?
When we do polyatomic ions and acids from those polyatomic ions, we're getting into us and ick, okay? Now, if we have binary acids, that means there's only two elements. We do not have polyatomic. These are fairly simple. Again, you need an H and an AQ. Yes, these are your hydros. I think that's what you were talking about. This is your hydro. Here's the element. Here's the ick acid. So what would you call HIAQ? Yeah, hydroiodic acid. Pretty cool. So hydroiodic acid. Compounds that contain water molecules bonded to their lattice structure. So these are ionic compounds, and they have water molecules actually bonded to them. Calcium chloride is not a hydrate. We call it anhydrous. That means without water. Anhydrous means literally without water. Calcium chloride dot H2O is a hydrate. Okay, count this one below it is a hydrate. It has this one right here is a hydrate.
Because it has two.
This one has two water molecules bonded for each calcium chloride in the structure.
Isn't there only one calcium chloride?
I did.
Remember, an ionic compound is an array. Calcium ions bonded to chloride ions, bonded to calcium ions, bonded to chlorine, right? It's a repeating array, so your positives are surrounded by more than one negative, but the numbers are for every one calcium, there's two chlorines.
Okay, so that's like just one and every.
So this is our formula unit. This is for every one calcium in our structure, there's two chlorines. So what it's saying, for every one unit, one formula unit, there's two waters. So if you have 6 calcium chloride units, there's 12 waters. Okay, when you write the formula for a hydrate, you do need that decimal. Then the number tells you how many water molecules are attached. When you name it, you just use your prefixes, like covalent molecules. So it's di for 2, hydrate. If you have 5 waters bonded to you, what are you going to be? Pentahydrate. So this is, the name of this compound is calcium chloride dihydrate. What would be the name of MgSO4 period 7H2O?
Magnesium sulfate. Septa.
Yeah, it's not the.
And I talked longer than 5 minutes.